Joe Rogan has finally revealed the shocking image taken by the Webb Telescope and finally shows what Oumuamua looks like. In 2017, astronomers noticed something unusual passing through our solar system. It was Oumuamua, the first known interstellar object to visit us, but what do the images of Oumuamua reveal about its true nature, and could these images change everything we know about the universe? Let's dive into the details and find out what this interstellar visitor can tell us about the universe beyond our solar system. In 2017, the world of astronomy was hit by a huge surprise. The Pan-STARRS-1 telescope in Hawaii, which constantly monitors strange events around the universe, noticed something quite unusual. It was Oumuamua, the first observed interstellar object to visit our solar system. The discovery of Oumuamua raised many questions among scientists and almost everyone who heard about it. People were fascinated for obvious reasons. Here was concrete proof that things from outside our solar system could migrate. And now the James Webb Space Telescope has finally captured a shocking image of the object that has revealed its true nature, but Oumuamua was not exciting because of its origin. This object had some pretty strange properties that set it apart from the normal comets and asteroids that scientists are used to seeing. First, its shape was something else. Most space rocks we encounter are somewhat rounded or irregular, but Oumuamua was tall and thin. It was a rock the length of a football field but a fraction of its width, then its path is through space. Oumuamua retreated into our solar system at a speed and angle that made it clear that it did not come from here. It moved so fast that it just passed, it didn't get stuck orbiting the sun like most space debris that comes our way. And perhaps one of the most puzzling things about Oumuamua was the lack of a comet tail. Most comets have iconic tails of gas and dust behind them. Oumuamua did not have one, although it was close enough to the sun where one would expect the comet to eject material. Oumuamua remained tailless. That was a big clue that this was not your typical comet or asteroid. Oumuamua's arrival was like nothing we had ever seen. Its interstellar origin, unusual shape and unexpected behavior prompted questions from everyone from professional astronomers to casual space fans. What exactly was Oumuamua? Where did it come from? And what could it tell us about the universe beyond our solar system? How did the James Webb Space Telescope detect this strange object? The James Webb Space Telescope is an essential piece of technology in space exploration. Named after James E. Webb, a pioneering NASA administrator who played a critical role in the Apollo missions, the telescope is the next step forward in space observatories. Its journey from design to final frontier is a story of collaboration, innovation and the unwavering human spirit. The idea for the James Webb Space Telescope began to take shape at the end of the 1990s as a successor to the Hubble Space Telescope, with the aim of looking deeper into the universe than ever before. Telescope developed an international collaboration by NASA with significant contributions from the European Space Agency and the Canadian Space Agency. The telescope was designed to answer fundamental questions about the universe's earliest stars and galaxies, the formation of solar systems, and the possibility of life elsewhere. At the core of the telescope's capabilities are its advanced instruments and a massive 6.5-meter main mirror composed of 18 hexagonal gold-plated beryllium segments. This mirror is significantly larger than Hubble's mirror, so the telescope can collect more light and see objects in much more detail. The design of the telescope allows it to observe in the infrared spectrum, which is essential when looking back in time to the first galaxies formed after the Big Bang, when the expanding universe extended its light into infrared wavelengths. The telescope is equipped with 4 main instruments: a near-infrared camera, a near-infrared spectrograph, a mid-infrared instrument and a fine-tuning detector/near-infrared camera and a slitless spectrograph. Each instrument has a unique role, from taking detailed images to analyzing the chemical composition of celestial bodies. One of the most novelties of the James Webb Space Telescope is its ability to observe the atmospheres of exoplanets, which could detect signs of habitation or even life. By analyzing starlight as it passes through an exoplanet's atmosphere, the telescope can detect chemical signatures that could indicate the presence of water vapor, carbon dioxide, methane and other key molecules. The path from the telescope to the stars was not without problems, such as technical obstacles, budget overruns and delays. But after years of careful planning, construction and testing, the telescope was finally launched aboard an Ariane 5 rocket from French Guiana on December 25, 2021. The telescope then entered lunar orbit toward the second Lagrange point, approximately 1.5 million kilometers from the Earth, where it remains surrounded by the heat of the sun and protected from light, offering an unobstructed view of the universe. Since its launch, it has begun to fulfill its promise, producing stunning images and data that will transform our understanding of the universe. Its early achievements include capturing the most detailed views yet of distant galaxies, observing the atmospheres of exoplanets, and studying the dense clouds of cosmic dust where new stars and planetary systems form. When Oumuamua arrived, the James Webb Space Telescope became our best chance to get a closer look. Its array of instruments and unparalleled sensitivity to infrared light meant it could record details of Oumuamua's shape, size and perhaps even composition that other telescopes could not. The addition of the Oumuamua telescope observation was a major space event. Scientists and space enthusiasts were on the edge of their seats, waiting to see what the telescope would reveal. The forecast was about wider impacts. This was our chance to gain knowledge that could apply to others like it, and perhaps even shed light on the building blocks of other solar systems. It tested our ability to observe and understand phenomena from other star systems using the most advanced tools at our disposal. The insights expected from this observation could open new boundaries in the understanding of the universe, making it a defining moment in the field of astronomy. Why is this item so fascinating? Ever since Oumuamua passed through our solar system, it has been the star of many scientific head-scratchers. One of the biggest controversies is its shape. At first some thought it looked like a cigar, long and skinny. But then a new camp began to suggest that Oumuamua might actually be pancake-like, flat and wider. This is central to understanding Oumuamua's journey through space and what forces it may have encountered along the way. Diving deeper, scientists had all kinds of theories about what Oumuamua was made of and where it came from. One theory is the nitrogen ice hypothesis. According to it, Oumuamua is a chunk of nitrogen ice that broke off from a Pluto-like world in a distant star system. If true, it would explain its unusual acceleration as it passes the Sun and tell us a little about its surroundings. One of the most talked about theories is the idea that Oumuamua may be an artificial object, perhaps a probe sent by an advanced space civilization. This speculation is fueled by its unusual acceleration as it passes through our solar system, which some scientists say may indicate a light sail, a thin, broad surface carried by solar radiation. Although this theory leans more towards science fiction and lacks concrete evidence, it shows how much influence Oumuamua has had on our imaginations and our desire to find connections with other intelligent life in the universe. Another compelling hypothesis suggests that Oumuamua may be a fragment of a broken planet or a building block of a planet known as a planetesimal from another star system. This theory says that Oumuamua can be a piece of a larger celestial body that was torn apart by the gravitational forces during a possible close encounter with a star or giant planet. Such an event could explain its elongated shape and unusual trajectory and provide insight into the violent processes that can occur in young solar systems. While the true nature of Oumuamua may remain elusive, each theory contributes to a broader understanding of the processes occurring in our universe. But with something as unusual as Oumuamua, it's easy to let your imagination run wild. Sure, Oumuamua is strange, but jumping straight to extraterrestrial explanations without hard evidence is not how science works.